Hi team, we are now starting chapter 11, 11.1, sequences and their notations. But first, let's give a shout out to Dr. Ann Hoskariog, Dr. H, who's been helping me with the closed captioning for all of my videos. Thank you, Dr. H. And just to play with you a little bit, supercalifragilisticexpialidocious. Good luck with that one. Okay, so number one, we want to talk about what a sequence is. Sequence is a function, we'll just like if we use f of x, we can use a of x, whose domain is the set of natural numbers or positive integers. Think of it like the counting numbers, 1, 2, 3, 4. And this function produces a pattern. So the terms of the sequence are the function values, a when you plug in 1, function a when you plug in 2, function a when you plug in 3, and so forth. When we're referencing the terms in the sequence, we usually write a to the n instead of the function notation a of n. So the terms of the sequence are written as a sub 1 is the first term, a sub 2 the second term, a sub n just means some general nth term. So if we're looking at this example here, notice this pattern, 2, 4, 6, 8, they're even numbers. You have the little 3 dots, the ellipses there to 2n. That's really what our function looks like. 2 times some positive integer n. So 2 would be considered the first term. This would be our a sub 1 is 2. Our a sub 2 is 4. Our a sub 3 is 6, and so forth. So a sequence that continues indefinitely is called an infinite sequence. A sequence that is defined only for the first n positive integers is called a finite sequence. In other words, there's an end to it. There are typically 2 types of formulas for these sequences. The first one is called an explicit formula. What that means is we can go directly to the nth term, okay, using the position. If I want to know what is the 25th term in the sequence, I could plug in the n directly and I can get my 25th term. Another type of formula is called a recursive formula. And that's a formula where every term is defined by a term before it. So we always have to know the initial term or terms of that sequence in order to determine what the next number is. For example, we have this sequence of 5, 10, 15, 20, 25. They're giving us the first 5 terms. Well, we know they're multiples of 5. So the explicit formula is given that any nth term is 5 times n. So notice the third term, 15, is 5 times 3. The 5th term is 5 times 5. That means the 6th term would be 5 times 6, or 30. So we can go all the way out to the 100th term. We know automatically the 100th term would be 500. The recursive formula states that our first term is 5, but then any term after that is the previous term plus 5. So notice how that's represented. If I want to know the nth term, this here represents the term before it. So I would have to know if the 6th term is 30, then I would add 5 to it to get the 7th term, that would be 35. The nice thing about the recursive formula, it has to give you at least the first term, but I can't go directly to the 100th term. I would have to find 1, then 2, all the way up to 99 in order to find the 100th. We also have a new term called a factorial. N factorial is written as n to the exclamation mark, so that's read as n factorial. And it's the product of all the consecutive positive integers from 1 to n. So here it would say n factorial, we would multiply n times the number before that, times the number before that, all the way down to 1. A quick example is if we had 5 factorial, that means we would take 5 times 4 times 3 times 2 times 1, which would give us 120. Something that is important to note is 0 factorial has been defined as 1. It's used a lot actually in statistics and probability, which is why they've had to define that 0 based on some of our formulas as being 1. But let me show you where that is in your calculator. So as you remember, I said that it's used a lot in probability. So in order to put in 5 factorial, we put in the number 5, go to math, but notice up here at the top, we have numbers, complex numbers, probability. Some of you may have fractions or not, but scroll over to probability and you'll see that exclamation mark of 4. Hit enter to put it in and hit enter again, and it automatically gives you the 120. So again, that's under math, probability, and then you find your factorial. So in example 1, each sequence is explicitly defined. In other words, it's giving us a formula where we can go directly to the nth term. You want to write the first 3 terms and then skip to the 30th term of each sequence. So for example A, in order to find the first term, we plug in 1 everywhere there's an n. It's a plug and chug. So our first term is a -1/2. Our second term, we plug in a 2 for n, and we get a positive 1/4. Plug in a 3 for n, we get a -1/8. Before we jump to 30, I want you to notice that our sequence here alternates signs. It goes from -1/2 to a positive 1/4 to a -1/8. This -1 to the power of n is one way of getting that oscillating sign, those alternating signs. If you want it negative, you can do -1 to the n. If you start with a negative, if you want to start with a positive, you could do -1 to the n-1 or n+1. Now let's get down to the 30th term. -1 to the 30th divided by 2 to the 30th. Well, again, -1 to an even exponent is going to give us a +1. And 2 to the 30th is pretty large. Normally, I would just have you leave it as 2 to the 30th power. But if you were to multiply it out, I've already written it out here. It is 1,073,741,820 But again, I'm fine if you have an exponent that large to just go ahead and leave it as 2 to the 30th. Part B is a little bit different because it's given to us as a piecewise function, but that's fine. Our instructions is if it's an odd term, then we use that top portion. If it's an even term, we use the bottom portion. B sub 1, our first term is odd, so we're going to use that top formula. We will have 1 minus 1 factorial divided by 3. Remember, 0 factorial is defined as 1, so we get a 1/3. And if you forget, you can put 0 factorial in your calculator. It will give you a 1. B sub 2, our second term, so it's even. So we're going to use that second piece, 2 times 2 cubed. Please, please, please do not forget your order of operations. We have to cube the 2 before we multiply by the 2. So 2 cubed is 8, and that gives us a 16. B sub 3 is an odd term, so we're going to use the top one. This time plugging in 3, so 3 minus 1 quantity factorial divided by 3. We get 2 factorial divided by 3. 2 times 1 is 2. So we get a 2/3. We can also jump down to the 30th term. And again, 30 is even, so we use the bottom. 2 times 30 cubed. So that's going to give us 2 times 27,000, which equals 54,000. Our last example gives us a recursively defined formula, which again means that we have to know the term before it. And we want to write the first 3 terms of the sequence. Notice that they had to give us the first term in order to start. So even though it said the first three, let's go ahead and do the first four so we can get the practice, because a sub 1 is given to us. So we know a sub 1 is 1. To find a sub 2, we would have 3 times. So notice you could plug in that 2 for your n plus 2, which means 3 times a sub 1 plus 2. A sub 1 is 1. So we get 3 times 1 plus 2. We get 3 times 3, which gives us 9. So again, this n minus 1 just means the term before it. So a sub 3, the third term, would be 3 times a sub 3 minus 1 plus 2, which equals 3 times a sub 2. So again, we're looking for a sub 3, so we got to use a sub 2 plus 2, which gives us 3 times, this time 9 plus 2. 3 times 11, which is 33. So notice how we knew a sub 1, so we used a sub 1. We knew a sub 2 was 9. Here we plugged in 9. So we're using that previous value. Just one more for good measure. 3 times a sub 4 minus 1 plus 2 means we're looking at 3 times a sub 3 plus 2, the previous term. Our previous term was 33, so we plug in 33 plus 2. We get 3 times 35, which gives us 105. So that's the difference between the recursive formula, where you have to know the term before it, or possibly 2 terms before it if it puts n minus 2. Okay, but again, they have to give you enough terms in order to satisfy the definition in that formula. All right, that's an introduction. I hope you enjoy. If you have any questions, please stop by and see me. Thanks. Bye.